Now let's talk about relationships between sides of a triangle. Let's take a look at these examples. Which of the following can be lengths of the sides of a triangle? 6, 10, and 15 are three different lengths. Can we put them together to make a triangle? How about 5, 10, and 15? Can we put those together to make a triangle? Well, because they're sides, we don't know much about their measures until maybe we take a look at it. So I have two demonstrations of triangles that use the lengths 6, 10, and 15, or trying to make triangles at least, and 5, 10, and 15. So in this demonstration, notice that it's the length of AC, the bottom length right here, that is 15. Same thing for the other picture, AC, this bottom length right here is also 15. The two other lengths that I'm going to be moving, like this one, is going to be changing just in its direction, but notice the side length of AB will always be 6, and the other side length of BC will always be 10. So I'm going to try to connect to bring the vertices, the points of B together. Since they are the same point, they should be touching to make a triangle. So there it is. I've connected it, and I can make triangle ABC. Let's go to this picture where the length of AB I've now shortened to be 5, but I've kept the length of BC the same as it was in the other picture of 10. And the bottom length, as you remember, is still 15. So now I'm going to try to bring these two sides together. It looks like it can probably work. Well, they're not quite touching yet, and I'm getting lower and lower. You can see that those 2 points are not on top of each other yet. If you look closely, I'll bring this a little bit lower, and I can't get them to touch until, well, there it is. Now they're touching, but do I have a triangle? So let's think about this. Let's think about what these lengths are. In this picture, remember that from A to B, that had a length of 5, and from B to C, that had a length of 10. And remember that this original bottom length is 15 all the way across. Look at those numbers. 5 plus 10 all together makes 15. Well, that doesn't make a triangle because when they connect, they're going to be the same length. 5 plus 10 equals 15. They're going to lie right on top of that third side to not make a triangle. But rather in this picture, when the bottom length was 15, these two sides, 6 and 10, when I add those together, 6 and 10 makes 16. And that's long enough that these two sides can prop up to be greater than that third side. Or rather, that third side of 15 is less than what these two sides added up to be. So then it's short enough that the other two sides can connect without lying down flat like in this picture. So remember, what we're asking ourselves is look at the longest side and let's compare it to the sum of the other two sides when we add the other two sides together. And hopefully this longest side is less than the sum of the other two sides. Is 15 less than 16? Yes, it is, just like we saw in the diagram. So yes, these lengths can make a triangle. How about in this picture? This was the other demonstration we saw. Take our longest side, add the other two sides, and compare. Is the longest side less than the sum of the other two sides? That's our question. Well, 5 plus 10 makes 15, and 5 is not less than 15. So, no, these three lengths can not make a triangle. So let's take note of what we just noticed in the demonstration and in the examples. For the relationships between sides of a triangle, the longest side must be less than the sum of the other two sides. And we remember that sum means add. We add the other two sides. Let's go take a look at some examples, and then we might be adding to this note here. The lengths of two sides of a triangle are 6 and 10 as shown in the figure. There it is. What is the range of possible lengths for the third side, x, of this triangle? So remember what we just discovered before, that when one of them is the longest side, it has to be less than the sum of the other two sides, 6 plus 10. So x has to be less than 16. But what if x is not the longest side? I mean, it looks like it is in the picture, but maybe it's not, or maybe the picture is not drawn to scale. So if x is not the longest side, then that would mean 10 is the longest side. So then 10, the longest side, would have to be less than the sum of the other two sides, or x plus 6. Well, if we're solving this inequality for x, we would subtract 6 from both sides of the inequality, and we would get that 10 minus 6 is less than x. And therefore 10 minus 6 is 4, so 4 is less than x. So putting these together, what this is saying is that x has to be less than 16, but x has to be greater than 4. Remember, if we turn it around, the symbol gets turned around with it. So x has to be greater than 4, but less than 16. How do we write that together? X in the middle, less than 16, but greater than 4. Notice in a combined inequality like this, the lowest number goes to the left, like when we're listing numbers or writing them on a number line. So x is anything between 4 and 16. Could be 4.1, could be 5, could be 10, lots of possibilities. Let's take a look at a similar example. The lengths of two sides of a triangle are 6 and 10 as shown in the figure. There they are. Describe the range of possible values for x. Notice this time that the third side is labeled 2x plus 4. Now just like we did up here, we're going to say, well, what if 2x plus 4 is the longest side? So we remember that the longest side, in this case the expression 2x plus 4, has to be less than the sum of the other two sides, 6 plus 10. So 2x plus 4 has to be less than 16. I'm going to pause there for a moment and take a look at the other possibility. What if 2x plus 4 is not the longest side? Then 10 would be the longest side, so 10 would have to be less than 2x plus 4 plus 6. Now, I want to point out something that we did in the problem above, is that we said if x is the longest, then x is less than the sum. And when x was not the longest, notice that ultimately when we got x by itself, it is greater than the difference of the other two sides, or subtracting the other two sides. So that's one quick way to look at comparing the third side of the triangle. So the difference between 10 and 6 has to be less than what we're calling the third side of the triangle, which is 2x plus 4. So see, we've got the third side is less than the sum, and the third side is greater than the difference. So here's another way that we could look at this. Instead of doing two of them separately, we could take the third side, 2x plus 4, and put it between the sum, 6 plus 10, and the difference, 10 minus 6. And we could start the problem from there. Notice that's the same thing we have here, we just did it in parts. 16 was made of 6 plus 10, and 4 was made of 10 minus 6. We can solve this equation, or inequality, excuse me, right from here. 10 minus 6 is 4. Simplifying both sides over here, and 6 plus 10 is 16. And now we'll solve the inequality by getting x by itself. Subtracting 4 from all three parts of the inequality makes 0 less than 2x less than 12. And finally, make the 2 go away from the x, divide all parts by 2, and that leaves us with 0 is less than x is less than 6. These are all the possible values of x, or the range of possible values for x. Let's go back to our note and write the rest of the relationships between the sides of a triangle. So not only do we know that the longest side has to be less than the sum of the other two sides, but in general, the third side of the triangle, whether it's the longest or not, has to be less than the sum of the other two sides, but greater than the difference between the other two sides. So the third side, like in this picture, we could call AC the third side, has to be less than adding the other two sides, AB plus BC, but greater than subtracting the other two sides, AB minus BC. So adding to the right and subtracting to the left for the smaller number.